Hello everyone. Today we are presenting the final deliverable of a master project in sustainability and circular economy conducted at UPC EEB. The core objective of this work is to evaluate the environmental and business sustainability of two protein sourcing in Spain consumption context, specifically 1 kilogram of beef and 1 kilogram of tofu. We adopt what is called a cradle-to-plate approach, which means we capture all environmental impact from agricultural production through household consumption. This scope is important because it reflects the complex responsibility chain faced by Spain consumers making dietary choices every single day. This analysis aims to quantify major environmental indicators, principally global warming potential, land use, and eutrophication, to provide evidence-based guidance on whether shifting from animal-based to plant-based proteins represent a viable and sustainable transition path in the Spanish context. You may ask, why is a Spanish-specific study necessary? The scientific literature constantly demonstrates that replacing meat with plant-based alternatives can reduce greenhouse gas emissions by 30% to 90%, depending on the production system, and assumptions used. However, most existing LCS studies focus on the United States, Northern Europe, or generic global context. This raises an important question. Are these conclusions transferable to Spain, given our specific energy mix, agricultural practices, and import patterns? To address this gap, we employ the Recipe 2016 midpoint method implemented in OpenLCA software using the EcoEvent database. This choice ensures a robust and harmonized comparison, standardizing both system boundaries and impact assessment approaches across both products. Although our study is centered on Spain as the consumption region, we acknowledge that detailed Spanish-specific inventories are limited in public databases. Therefore, we use European average dataset as proxies for electricity, water, and some agricultural processes. This is a methodological choice that we explicitly justify and with limitations we discuss in detail in our full report. This approach represents best practice for food LCS studies in contexts with limited regional data as confirmed by recent review in the scientific literature.
Now let me walk you through how we actually model each scenario. The beef scenario models a complete cradle-to-plate system encompassing livestock production, transport, slaughtering, processing, retail storage, and household cooking. The agricultural stage is modeled using the EcoInvents dataset for beef cattle production on pasture and feedlot. This comprehensive dataset captures pasture maintenance, feed production, enteric fermentation, which is the methane emissions from the cow's digestive system, and manure management. Importantly, it accounts for all animals on the farm, including young bulls, reflecting on the full herd composition required to produce just 1 kilogram of final meat. Transport logistics include refrigerated trucking over 500 kilometers from slaughterhouse to retail using a Euro 6 diesel lorry, consistent with realistic Spanish distribution distance. We also model water supply using the European tap water market dataset and electricity using the European medium voltage electricity mix, again as a proxy for Spanish conditions. We explicitly exclude packaging because both beef and tofu on comparable materials, plastic trays, films or vacuum packs in similar quantities. This allows us to focus the analysis on the major drivers of environmental impact without compromising the fairness of the comparison. The tofu scenario follows the identical cradle-to-plate structure but reflects the plant-based supply chain realities for Spain. The raw material sourcing is modeled using the EcoInvent dataset for Brazilian soybean production because Brazil is the principal source of Spain's imported soybeans. The conversion ratio is 0.6 kilograms of soybeans per 1 kilogram of tofu, based on industrial processing data from the literature. The logistics is divided into two distinct phases. First, we have the transatlantic bulk carrier shipping from Brazil to Spain, modeled at a 6.1 ton kilometers distance. This captures the long distance oceans transport required for international supply chains. Secondly, we model domestic road transport using Euro 4 freightliners, which are the most common truck type in Spain, at 0.5 ton kilometers distance. The industrial processing steps includes energy-intensive operations, grinding, soaking, heating, coagulations, and pressing, modeled with the European medium voltage electricity markets to ensure consistency with the beef scenario. As with beef, packaging is excluded for comparability reasons.
Now, let me present the headline results, which are quite striking. For global warming potential, which is the most commonly cited environmental indicator, we find the following results. First, the carbon footprint of beef is 32.86 kg of carbon dioxide equivalent per kilogram consumed. For tofu, the carbon footprint is just 2.14 kilograms of carbon dioxide equivalent per kilogram consumed. This represents a reduction of 93.5%. This confirms the expected direction from the literature, but now we have rigorous context-specific evidence for Spain. Land use is another crucial indicator, especially for protein production systems. For beef, land use reaches 71.74 square meters annual crop equivalent, and for tofu it's only 2.5 square meters annual crop equivalent. So this represents a reduction of 96.5%. This result is particularly significant because beef requires vast agricultural areas for pasture and feed crops, whereas tofu's footprint is much smaller, reflecting the inherent efficiency advantages of plant-based systems. Beyond these headline indicators, additional impact categories such as freshwater eutrophication, marine eutrophication, and fine particulate matter formation also show tofu outperforming beef by typically 1 order of magnitude. This confirms that the environmental benefits extend well beyond climate change alone. Now, understanding where this impact originates is critical for identifying effective mitigation strategies. The hotspot profiles of the two scenarios are dramatically different, and this has important implications for how each product can be made more sustainable. First, for beef, the concentration is extreme. 99.54% of the global warming impact originates from the livestock production stage. This includes several things, like enteric fermentation, which is methane emission from the cow's digestive system, which is a highly potent greenhouse gas, and from manure management. By contrast, transport refrigeration accounts for only 0.46% of total impacts. Electricity and water together contribute less than 0.01%. What does this tell us? It means that improving beef sustainability must focus almost exclusively on farm-level intervention, like improving feed efficiency, reducing herd size, or even implementing methane abatement technologies. Optimizing transport logistics or processing energy cannot materially change the overall environmental outcome. Then, for tofu, the impact distribution is much more heterogeneous. Soybean cultivation in Brazil accounts for 70.85%. Then maritime freights across the Atlantic represent 11.99%. Electricity for processing contributes at 11.37%. Then road freight within Spain at 5.43%, and finally tap water as a negligible 0.37%. This distributed profile indicates that tofu's sustainability depends on multiple factors. First, the agronomic practice used in Brazilian soybean fields, the fuel efficiency of transatlantic shipping vessels, the source of electricity used in tofu factories, and also regional logistics efficiency. It is not dominated by a single stage as beef is. These contrasting hotspot structures have significant implications for business strategy and for how companies might position their product, which we discuss next.
From an environmental point of view, with the analysis that we have, it is clear that tofu is the better product for environmental impact. However, these benefits are not enough for the product to be exceptionally marketable. Therefore, we must translate our results into value for the product, for the Spanish consumer to find. Our business model identifies three core customer segments for Spanish tofu manufacturers. The first segment comprises of the vegan, vegetarian, flexitarians. The second group is health-conscious consumers, and the final group are environmentally conscious consumers. Each of them find value differently. For the first group, value is found through tofu's nutritional facts. The second group also, and for the final group, for tofu's environmental benefits. Now, distribution and customer relationship centers on product labeling and retail shelf positioning. Because consumer engagement is largely transactional, there is a low direct interaction between manufacturer and consumer. Packaging and nutritional information become the primary communication channels for conveying health and sustainability benefits. The revenue model is based on direct product sales through supermarkets and specialty retailers, with profitability dependent on volume and competitive pricing rather than premium margins. Given the bargaining power of large retail chains, cost efficiency in manufacturing becomes absolutely critical. Now, integrating circular economy principles into the tofu business model is important. There are several opportunities in the upstream level. We can valorize okara, the soybean residue from tofu production, as animal feed or compost instead of treating it as waste. This closes nutrient loops. At the processing stage, we can reduce energy and water consumption through heat recovery systems, all those higher efficiencies methods, and also a greener packaging. However, food products are rarely circularizable because the end goal is to be consumed and discarded. Therefore, it is hard to make this product into a circular economic model besides trying to make it greener.
Finally, this study provides a contextualized, rigorous reference for Spanish policymakers, companies, and consumers seeking to reduce the environmental footprint of protein consumption with maintaining nutritional adequacy and market viability. Thank you very much for your attention. We, of course, welcome your questions.